Welcome to Math Science History. I'm Gabrielle Burchak, your host. I'm a science communicator with a background in math and journalism. It's February, which means it is Black History Month. And today I'm doing a special podcast on the life of Benjamin Banneker, a Black mathematician and astronomer who literally and tangibly shaped the new capital of the United States, that is, Washington, D.C. It was late winter of 1791, and the air near the Potomac carried a sharp cold that made every breath feel like a measurement. A small camp stood at Jones Point near Alexandria, at the edge of what would become a 10-mile square of the new federal district. There was no skyline yet, no dome, no marble. There was only darkness, trees, water, and a crew trying to turn wilderness into coordinates. A lantern swung low, papers were weighed down with stones, metal tools caught faint light, and a man, whispering numbers and looking up at the sky, stood slightly apart from the camp's bustle. His name was Benjamin Banneker. He was not a general, he was not a commissioner, he was not a lawmaker. He was a Black man in a slave-holding country. And he had been there during the long night, doing what the work depended on, recording star positions, tracking time, and turning celestial motion into usable lines on Earth. Banneker was part of the early republic, which exposed a profound contradiction. The nation spoke in the language of liberty, but it had been built to deny liberty. It praised reason, but it fenced reason off by race. Yet, here was a self-taught Black astronomer doing precise federal work for the capital of the United States. Banneker was not in charge of the project, but his observations helped anchor it. He had watched the sky the way surveyors needed someone to watch it, patiently, accurately, and with enough mathematical skill to turn observation into evidence. And that raised the question at the center of his life, and at the center of the early republic. How did a self-taught Black astronomer become an authority in a country built to deny his authority? Benjamin Banneker was born as a free Black child on November 9th, 1731 in Baltimore County, Maryland. That first fact shaped everything that followed. Being born free did not mean being safe. It did not mean being treated as an equal. It meant Banneker's life began inside the narrow corridor of possibility, and that corridor could have closed at any time. His mother, Mary, was a free Black woman, and his father, Robert, was a formerly enslaved person from Guinea. Banneker grew up on his parents' tobacco farm near Baltimore. When he was 6 years old, his parents put his name on the deed, making him the beneficiary of 100 acres of land. Some of the sources on the following information are a bit vague. According to encyclopedic sources, in Banneker's early years, he was taught to read by his grandmother, who often read him the Bible. As Martha Ellicott Tyson noted in her 1854 writings for the Maryland Historical Society, Banneker was sent to a nearby one-room schoolhouse as a boy. Witnesses recalled that his only delight was to dive into his books, and I will post a PDF to that source on my website at mathsciencehistory.com. He was an inquisitive young man, and when he was in his early 20s, he disassembled a borrowed pocket watch to understand how it worked. Using that watch as a template, he then created a wooden clock that struck every hour. That clock continued to work until after he had died, meaning it lasted for 50 years. This clock was not a small thing. In the 18th century, precision was power. It was social standing made visible. A precise object could draw witnesses, and witnesses could lend to reputation. Banneker's clock did not erase racism. It did not dissolve barriers, but it did force a local community to face a fact that the clock worked, and he was a brilliant man. The clock also established a pattern that would repeat in his life. Banneker often built credibility through something that could be tangible and checked. He did not ask people to believe in him as an idea. He gave them an artifact that kept time. and later he gave them predictions that matched the sky. It is likely that as he became a teenager, he had to put his studies aside and work on the farm. In the 1770s, when Banneker was in his early 40s, a Quaker family named Ellicott moved into the area along the Patapsco River and built grist mills, which are buildings and grinders that crush or pulverize wheat, rye, or corn into flour or feed. The Ellicotts mattered in Banneker's life because they removed some of the barriers that made brilliance impossible to demonstrate. The Ellicotts were Quakers, members of the Society of Friends. They believed in human dignity and accountability, even in a society structured by inequality. This context matters. In 18th century America, being welcomed into intellectual conversation was not neutral. It was a form of permission. And in the Ellicott's orbit, Banneker was not treated as an anomaly or a curiosity. He was treated as a thinker. After the Ellicotts established their milling community along the Patapsco River in the 1770s, Banneker came into regular contact with them as a neighbor. Decades later, that proximity became pivotal. PBS reports that in 1788, George Ellicott loaned Banneker some astronomy books and instruments, which allowed Banneker to move from informal curiosity into serious astronomical calculation. The book loans mattered because advanced astronomy was not something you could improvise. It requires tables, texts, and tools. An 1863 article in The Atlantic later listed some of the works Banneker used, including astronomical tables and treatises that were standard references for serious practitioners of the time. And this is where empowerment becomes visible. The Ellicotts did not supply ideas. They supplied access. They did not validate Banneker's intellect by praising it, although they should have because he was brilliant. They validated it by letting him test it. With those books and instruments, Banneker could calculate, predict, and publish results that could be checked by anyone willing to look at the sky. And once Banneker's work entered public circulation, it could be evaluated by the same standards applied to any astronomer. That is how private ability became public authority. But what about the 20 years that led up to his meeting with the Ellicotts? During that time, Banneker kept learning. He obtained knowledge wherever he could and was predominantly self-educated. And for Banneker, that phrase, self-educated, often sounds like a solitary genius. But in practice, self-education requires an ecosystem. In those times, people learned on their own, but they learned with borrowed tools, borrowed books, and borrowed time. They learned because someone encouraged it. The conditions that made Banneker possible had been rare but authentic. First, he had lived in a household where literacy took root early. Once he could read, the world had not been limited to what he could see. It also included what others had recorded, calculated, and published. Second, he lived in an age and place where practical mathematics mattered. It was an age when almanacs were being printed and circulated everywhere. It was a place where essential surveying was being conducted around D.C. as the new country's officially established capital grew and expanded. As a result, land plotting and timekeeping were not abstract games. They were serious business, and Banneker was able to witness firsthand the essential applications of astronomy and mathematics. Third, he had crossed paths with the Ellicotts, and that relationship became the catalyst for Banneker's opportunities. The Ellicotts built a world where numbers mattered in ordinary life. Their milling community depended on careful measurement, and their work brought them into constant contact with maps, property lines, and the instruments that translated landscape into order. In that setting, Banneker's talent had somewhere to go. His precision fit the environment, and his mind fit the conversations. The relationship did not hand him a title. It opened doors to work where mathematics was not a hobby, it was a necessity. As Banneker's astronomical skill matured and his name became associated with serious calculation, He became connected to surveying work alongside Andrew Ellicott's team in 1791 when the new federal district was being laid out. The National Park Service later described Banneker as spending about 3 months at Jones Point, making astronomical observations that supported the boundary work. So what changed Banneker's life was not a sudden miracle. It was a steady transition from private study to public responsibility, shaped by time, access, and the seriousness of the work itself. By the late 1780s, Benjamin Banneker had moved beyond reading mathematics and astronomy. He had begun doing the work. He had performed serious astronomical calculations and accurately predicted the solar eclipse of 1789. And that achievement mattered because it placed him in a tradition that valued rigor and patience. In an America where Black intellectual authority was routinely doubted, Banneker's mastery did not come from rhetoric. It came from the long discipline of learning how the heavens moved and then learning how to express that motion in numbers. He had studied tables and learned how to produce them. He had treated time as something measurable and the sky as something that could be translated into geometry and calculations. At the center of that work was the ephemeris inside an almanac. This section turned astronomy into a practical calendar for ordinary life. Seasons, lunar phases, celestial timing, and the structures people used to plan their year. This was also where the Ellicott's role became concrete. Their influence didn't only operate through speeches or symbolism. It operated through proximity, encouragement, and the practical world of measurement that surrounded their milling community. The National Park Service described Banneker's life in terms that connected his astronomical labor to surveying and technical work, situating him in the realm of observation, calculation, and field practice rather than in legend. And here is where the legend becomes profoundly tangible. Once Banneker's calculations became advanced, the next step was the one that carried his name beyond his neighborhood: publication. We'll be right back after a quick word from my advertisers. Banneker had studied tables and learned how to produce them. He had treated time as something measurable and the sky as something that could be translated into these calculations. At the center of that work was the ephemeris that he had published inside an almanac. An ephemeris is a set of tables, or it's a data set that lists predicted positions of celestial objects. It's most commonly the sun, the moon, planets, and sometimes bright stars, and it predicts their positions at specific times and dates. It's like a schedule of the sky. And in the 1700s and 1800s, an almanac was a practical handbook for the year. The ephemeris was the part that made the almanac useful and trustworthy. It provided calendar accuracy. It told you when lunar phases occurred, when eclipses might happen, and how the length of a day changed through the year. It also provided timekeeping and navigation. Sky positions helped people keep time, and for navigators, it supported celestial navigation, especially with lunar data. Also, the ephemeris helped with farming and daily planning. Many readers used sunrise, sunset, seasons, and lunar cycles for planning work and travel. And it also provided public credibility. Producing an ephemeris required real mathematical astronomy. If the tables consistently matched what people saw over the year, it established your reputation as a serious calculator. When Banneker produced an ephemeris for an almanac, he wasn't just sharing opinions or essays. He was publishing precise predictions about the sky's timing and motions. And this is exactly the kind of work that built his standing as a mathematician and astronomer. Publishing expands the radius of a person's reputation. A community can admire your skills and still keep you contained. However, print did and still does the opposite. Print carries one's body of work into other hands, into other rooms, and into a wider public conversation. Banneker's almanacs began with the issue for 1792, first published the year prior in 1791. He then continued publishing his ephemeris annually through 1797. And those dates mattered because they showed sustained work over multiple years, not a single moment of attention. The almanacs also carried more than calculations. They carried a voice. The National Park Service notes that Banneker included quotations and sayings that challenged racist assumptions about Black capability. So Banneker's writings did two things at once. They demonstrated technical mastery, and they asserted a moral claim about who belonged in the world of intellect and public life. As Smithsonian Magazine described it, Banneker's almanacs took on broader cultural significance, precisely because they confronted racist assumptions about Black intellectual inferiority. The almanac was published by William Goddard and James Angell, the owners of the print shop that made the almanac. And as they began publishing Banneker's works in 1791, Banneker's story moved from the pages to the field. In 1791, Banneker assisted Andrew Ellicott's surveying team in the early work of establishing the boundaries of the new federal district. The National Park Service described him as conducting observations for about 3 months at Jones Point, making astronomical observations that supported the boundary work. Boundary work depends on precision and endurance. The job required someone who could keep careful records and sustain attention in uncomfortable conditions. Banneker had been there because his skills fit the work. At the same time, his name later became tangled in stories that grew beyond what the record supported. Some popular retellings exaggerated his role in the city's design, including claims that he recreated L'Enfant's plan from memory. The Smithsonian Libraries and Archives discussed how myths about Banneker accumulated over time and how historians worked to separate documentation from later embellishment. The American Philosophical Society also emphasized the importance of distinguishing the historical record from later legend, particularly around the boundary survey and its participants. This distinction did not diminish Banneker. Instead, it clarified him because the verified arc of his life remained remarkable. He had moved from local study to published work that established his name to technical participation in the founding boundary work of the nation's capital. Then something even more profound happened. In August 1791, Banneker wrote a letter that became one of the most famous political documents produced by an early Black American scientist. Banneker wrote to Thomas Jefferson in 1791, appealing for justice for African Americans and enclosing the manuscript of his almanac as evidence of Black intellectual ability. The letter, dated August 19, 1791, was preserved as a primary document. Banneker's strategy was direct and disciplined. He did not write as a supplicant. He wrote as a man addressing a contradiction. He invoked Jefferson's own ideals, especially the language of equality and liberty, and set them alongside the reality of slavery. Banneker called it pitiable that Jefferson could speak of equality while, quote, detaining by fraud and violence so numerous a part of my brethren under groaning captivity and cruel oppression, that you should at the same time be found guilty of that most criminal act which you professedly detested in others with respect to yourselves, unquote. Banneker then goes on to ask Jefferson and his men to, quote, wean yourselves from these narrow prejudices which you have imbibed with respect to them. And as Job proposed to his friends, put your souls in their souls' stead. Thus shall your hearts be enlarged with kindness and benevolence toward them. And thus shall you need neither the direction of myself or others in what manner to proceed herein, unquote. This is such a compelling letter, and I'm going to post a link to that on my website at Math Science History. The power of this letter also came from what he enclosed. He enclosed his work so that Jefferson could verify He enclosed calculations as evidence. He treated scientific competence as a form of argument and forced an influential public figure to respond. And Jefferson did respond. Jefferson's reply was dated August 30th, 1791, and it was preserved by the Library of Congress. In that reply, Jefferson acknowledged Banneker's work as evidence of Black talent, even though Jefferson's broader actions and beliefs did not eliminate the nation's contradiction. Jefferson wrote that Banneker's work provided, quote, proofs of talents equal to those of other, quote, colors of men. What did the exchange change? Sadly, Banneker's letter did not dismantle slavery. It did not transform the law, but it did create a public, documented confrontation between a Black scientific mind and one of the nation's most influential political theorists. It also left a paper trail that later generations could point to when people tried to deny that Black intellectual authority had existed at the nation's beginning. When Banneker's life is told carefully, it can be summarized through 3 authority objects, each one harder to dismiss than the last. First, there is the clock. It represents visible precision. Second, there are the calculations. They represent precision extended into prediction. And third, there are the publications, especially the almanacs and the Jefferson letter. The almanacs represent precision that traveled. The record also includes limits. The archive was uneven, and later retellings often amplified Banneker's role because people wanted a hero large enough to stand against centuries of denial. The American Philosophical Society describes how the limited documentary trail and the appetite for inspiring narratives contributes to the growth of myths around his story. But even without exaggeration, even without the glorification, his documented life remains extraordinary. He was born free in Maryland in 1731 and educated himself over the decades. He built a precise clock that made him locally renowned. He conducted serious astronomical calculations by the late 1780s and predicted the 1789 solar eclipse. He had published almanacs beginning with the 1792 issue, first issued in 1791 and continued through 1797. He had assisted Andrew Ellicott's 1791 boundary work with astronomical observations, including time spent at Jones Point. And he had written to Jefferson in August 1791 with a moral argument backed by scientific evidence, leaving a historical exchange that later generations could study. For Black History Month, Banneker's story does not need exaggeration to carry weight. His life already shows what happens when intellect meets opportunity, when precision becomes proof, and when a Black man in the early republic insists that the nation's ideals should apply to everyone. Banneker built authority the hard way, in wood, in numbers, and in words sharp enough to hold a country accountable. Banneker did more than map the stars and tangibly establish our capital. He stepped up to the country's leaders and asked that they, likewise, shoulder the same culpability for implementing measures to protect his people. Like Banneker, may we meet our difficult moments the way he did, with disciplined learning, public truth-telling, and direct pressure on leaders to protect human dignity. Thank you for listening to Math Science History. If you want the next episode as soon as it drops, just tap follow in your podcast app. Math Science History is brought to you by caffeine. Delicious, delightful, life-supporting caffeine. If you'd like to support the show, you can find the coffee cup link in our show notes or at mathsciencehistory.com. Just click on that coffee cup. Your donations don't really go to coffee, but they really do help cover production costs. The MSH theme is public domain from the late, great music composer and professor, Dr. Lloyd Rogers. All other music is public domain from Pixabay. Until next time, carpe diem.